All right, hi BC Part 1, here's your answer key. Question 1, okay, question 2, question 3 in blue, question 4 is in green, all right. Couple of things. Question 3 had a lot going on. It continues down below. Question 4, here's the rational function factored out, vertical asymptotes, roots. Here's number 3, proving that it is in fact even. I generally just do the even test first, okay? Finding roots, blast from the past. Cumulative course, boys and girls. Keep on top of your stuff, all right? Factoring. Difference of squares, look at that. Gotta keep on top of it. Gotta keep on top of it. Roots are 0 from right here, 2 root 2 from this factor, negative 2 root 2 from this factor, but 0 is a root of multiplicity 2. So graphing f of x, this is a perfectly reasonably acceptable graph. Okay? Number 5, Nancy said, Miss Yam, my grade in a class cannot be a continuous function because I'm not taking a test in your class constantly, all the time, every minute of the day. And I said, yes, I know, Nancy. So that's why I said, assume your grade fluctuates sinusoidally, okay? So here's my graph. I think all the important information. I need to see like these values, these values, these values, axis of the wave, okay? This graph right here shows me, where those critical values are, okay? I didn't say I wanted 2 periods, so I just graphed 1. And here are 2 equations, one in terms of cosine, one in terms of sine. In the first 30 days, how many times will you get a 95%? Twice. Okay, you get one on the 13th day. You get another one on the 24th day. The next one is in the 35th day, which is in the next month. So, okay. Number 6. Love number 6. Let's see who is really on top of their game. So I first started, I said sine of 1/2 x equals negative radical 3 over 2. So I just called theta 1/2 x, okay? And all I did here in orange was I just rewrote, so sine theta equals negative radical 3 over 2. And let's follow the orange first. So I said, okay, that means theta could be 4 pi over 3 or 5 pi over 3. But since theta was 1/2 x, that means x is 8 pi over 3 and 10 pi over 3. But when I take a look at those 2 numbers, they are beyond 2 pi. So you're saying, oh man, that's out of my domain. The domain is this. What do I do? So, and when I do an answer key, I usually try and be more thorough than not, but so then I went over to theta in orange again, and I said, well, I know that theta could be 4 pi over 3 and 5 pi over 3. Then I asked myself, since when I multiply by 2, this angle gets big and past 2 pi, I thought, well, what is the next smallest angle before 4 pi over 3 that would have a sine of negative radical 3 over 2. And that's where I got the green from. Okay, the next smallest angle is negative pi over 3. And when I solve it for x, I get negative 2 pi over 3, and I say, oh no, that's also not in the domain of 0 to 2 pi. So here, there is no solution. And then I said this, support this finding graphically by sketching y equals the sine of 1/2 x, which is this. Sketch this, y equals a sine of 1/2 x. Like basically when you are asked to support something graphically, you're basically asking someone to support this finding here with a graph. And so what I did here was I graphed this. Here is sine of 1/2 x. Notice that sine of 1/2 x has a period of 4 pi. And you'll notice that over the interval of 0 to 2 pi, which is the interval that I wanted to solve, there is no angle between 0 and 2 pi where the sine value is negative. That's a great question. That was a great question, I have to say. Number 7, why will 5 minus cos x equal 0 never have a solution? Well, this equation is this equation. And we know that there is no angle on our great universe whose cosine is 5. And even more to the point, we know that cosine values for angles exist between -1 and 1 inclusive, and that is it. And number 8, domain of this. Is that the question? Domain? Yeah, let me see. Is that domain? Yeah, domain. Interesting. The cardinal rule. Cannot divide by 0. So 1 minus sine x cannot equal 0. So sine x cannot equal 1. Oh my gosh, it's called a mistake. Sine x cannot equal 1. So x cannot equal pi over 2, or, let me just erase this. Okay, so x cannot equal pi over 2. When else is sine of x equal to 1? Not at 3 pi over 2, because that is when sine x equals -1. Very good. 5 pi over 2, right? Or what's the next one? 9 pi over 2. And you'll notice that if I try to list all of the angles over which sine x would equal 1, these angles differ by a multiple of 2 pi. And how do we capture all possible angles? We say x cannot equal pi over 2 plus any multiple of 2 pi n, okay? And where n is an integer. So you're saying x can't be 90 degrees plus any multiple of 360 degrees plus 90, because that will always land on the same terminal side. All right, goodbye.